Okay, here is our Laramie High School version of learning how to fill in an Aufbau diagram and use it to write electron configurations. So, Aufbau diagrams are going to have kind of some depiction like this, where we have orbitals. So in this one, we have a line representing each orbital. The large numbers here are our energy levels. And then our letters here are the orbital type. And then P's come in sets of 3, D's come in sets of 5, S's come in sets of 1. And this is their order in the atom, which we're going to learn how that's related to the periodic table as well. Okay? But there's 3 rules when we are filling out an Aufbau diagram. The Aufbau principle: electrons are going to occupy the orbitals with the lowest energy levels first. So we're going to fill from the bottom to the top in those diagrams. Okay, so fill bottom to top is another way to think about that one. The Pauli exclusion principle is an atomic orbital may contain at most 2 electrons, and they must have opposite spins. Okay, so again, if we were to amend this one, we're going to say fill bottom to top. Okay, this one, an atomic orbital may contain at most 2 electrons, and they must have opposite spins. Must have opposite spins. And the way that we show that is with an arrow pointing up and an arrow pointing down. So one of those is 1 electron, the other is the other, and the direction of the arrow is indicating spin, which is a quantum mechanical property, advanced particle physics. If you're interested, take it in college. Okay? All right, Hund's rule: electrons fill a set of orbitals in the same energy level, one at a time, before pairing. Okay? So we're going to look at several examples of Aufbau diagrams here. Okay? So, first example, right here. So we have some arrows filled in. So these are representing electrons. There's 22 of them. And this one is incorrect. Okay? If we look at our rules, again, we need to fill from the bottom to the top. We need to have 2 electrons per orbital with opposite spins. And we fill a set of orbitals before we pair them. One orbital at a time before we pair them. Okay? So if we look at this, did we fill bottom to top? Well, no. Here we have a single arrow. We have a single electron hanging out, and we moved on. We need to fill that before we can move on. So that was the mistake for this Aufbau diagram. Okay. Now, if we look at this one, okay, this one I am filling from the bottom to the top. Okay. I have two electrons here with opposite spins, 2 here with opposite spins. This one looks good, but right here, they have the same spin. Okay, so that is a violation of Pauli's exclusion principle because they must have opposite spins. So that one is not correct. All right, here's another one. This one we've filled from the bottom to the top. Everybody has opposite spins, but when we get up here, we have 2 in the first orbital and 1 in the next orbital. But when we have orbital sets like this, we should fill 1 electron in each orbital before we go back and pair them. Okay? So if we were to take an empty Aufbau diagram and we were to fill this for the element titanium, okay? If I were to ask you to fill this for the element titanium, Ti, okay? You're going to look at the periodic table and you're going to see titanium's atomic number is 22. Okay, and that's going to matter for this because we're looking at electrons, and right now our electrons are the same as our protons, and our protons are the atomic number. So we have 22 electrons to fill into this diagram. Start at the bottom. 1, 2 gives it 20 more to go. Moving up, 3, 4. When you get to a set, put 1 in each, so 5, 6, 7. And then we go back and we pair 8, 9, 10. 12 more. 11, 12. 13, 14, 15 before we pair them up, 16, 17, 18. Okay, 19, 20, and we have 2 left, 21, 22. We would not pair those last 2. Okay, so find the element, find its atomic number, and then you can fill in the Aufbau diagram. Now, after you fill in the Aufbau diagram, you can use it for lots of stuff. First, unpaired electrons. Well, that's easy. We just look at arrows that don't have a partner. So this one has 2 unpaired electrons. Okay, valence electrons. Now remember, our valence electrons are going to be our highest energy level electrons. Well, these numbers are the energy levels. The highest energy level that we have electrons in is right here, level 4, and it has 2 electrons in it. Okay, I know these look like they're higher, but they are level 3. It's just we have a little overlap in our energy levels. So level 4 is our highest. It has 2 electrons. So 2 valence electrons for titanium. Okay, and finally, we can use this to write the electron configuration for titanium. If you look, we started here in the 1s, and we put 2 electrons in there. So that's a 1, whoop, gotta get my paper still here. 1s2 is the first part of this electron configuration. Then we went here and we put 2 electrons in the 2s. So 2s2. In the 2p, we filled it up with 6 electrons. So 2p6. Next is 3s2. Probably going to run out of space here. Then 3p6. 4s2. I'm going to bring it down here, but normally I would keep this all in a line. 4s2. And then 3d2. Okay, so that is how an Aufbau diagram works. And if you have questions, come ask your teacher in class.